And this is part 3. We're in Chapter 17, SEM2, Confirmatory Factor Analysis. This is part 3 of my video series on it. With the last part of my video series, we were on page 11 of Chapter 17, and we were just about to begin a section headed Reliability and other psychometric properties of the model. In the previous video, we talked about how the measurement model proposed by Dr. O'Day displayed a good fit to the data. Having got over that hurdle, we can now turn our attention to see whether the reliability and validity of our proposed model is adequate. When researchers discuss psychometric properties, they're usually discussing reliability and validity. Reliability is the extent to which a set of scores is consistent or stable. Validity is the extent to which a set of scores actually measures the construct that it was intended to measure. One of the benefits of structural equation modeling approach to confirmatory factor analysis is the fact that it provides researchers with procedures to assess specific types of reliability and validity as displayed by the measurement model. Page 12, we have a great big table. On page 12, we have a table that's headed Table 17.2, Reliability, Validity, and Other Psychometric Properties of the Latent Factors and Manifest Indicator Variables that Constitute the Measurement Model. Let's take this table just one column at a time. First column on the left is headed Factors and Indicators. We have the factor exercise behavior is measured by the indicator variables V76 and V79. Now, I hope that sounds familiar. If you look at the handout that I sent to students in my class, the handout is called P400 Additional Exhibits for Chapter 17. The first page of that handout provided the measurement model that Dr. O'Day was going to assess. One of the factors that she was going to assess was exercise behavior factor. It was measured by the indicator variables V76 and V79. That is exactly what we see in Table 17.2. The factor was exercise behavior, and these are the indicator variables that measured it. Another factor was health motivation. These are the indicator variables that measure it, and so forth. We have a group of 3 columns headed results for the indicator variables, that is, for the individual questionnaire items, and we have this last set of columns is headed results for the composites. We'll get to those in a second. So this is our table. What does the text say in describing the contents of that table? I'm on page 13. Halfway down page 13. Within the context of confirmatory factor analysis, it's useful to think of factor loadings as path coefficients that represent the size of the effect that a latent factor has on the manifest indicator variable. Standardized factor loadings generally range from -1 through 0 through +1, with values closer to 1.0 indicating a stronger effect. The indicators with larger factor loadings and absolute value are generally viewed as being more important measures of the underlying factor. One of the advantages of confirmatory factor analysis is the fact that it allows researchers to assess the reliability of the manifest indicator variables included in the model. The reliability of a given indicator variable can be computed by squaring the standardized factor loading for that indicator variable. Now, what are we talking about here? Let's go back to the big long table. Table 17.2. And in fact, let's look at that handout. The handout that I gave to everybody in my class, the one called P400 Additional Exhibits for Chapter 17. The first figure was the confirmatory factor analysis model. One of the underlying factors was exercise behavior. It was supposed to be measured by V76 and V79. Well, what's the reliability of V76 as a measure of exercise behavior? What's the reliability of V79? To find out, we look at the table. Under the heading Results for the Indicator Variables for the individual items, we have under the column Standardized Loading. For V76 as a measure of exercise behavior, standardized factor loading was 0.90. Okay, that's the size of the standardized factor loading, which is essentially a standardized path coefficient. But what about reliability? To convert that into a reliability coefficient, you square it. Standardized loading of 0.90, if you square it, 0.90 times 0.90 is 0.81. So the item reliability for item 76 as a measure of exercise behavior, the item reliability is 0.81. For item V79, size of its standardized loading is 0.66. Let's square it. 0.66 times 0.66 is 0.44. That's the item reliability for that item as a measure of the factor exercise behavior. Now let's go back to the text where I'm making sense of it, where I'm interpreting it. We go back to page 13. Okay, reliability of given indicator variable is computed by squaring the standardized factor loading for that indicator variable. Okay, so we have looked at the table and we've seen what the reliability indices are for those indicator variables as measures of the factor. In a minute we'll come back to that and we'll talk about whether it's relatively good, relatively bad. But now let's continue with the text that is on page 13. Page 13 goes on to talk about another psychometric property. In general, an instrument displays convergent validity if it displays substantial correlations with other instruments known to measure the construct of interest. Within the context of confirmatory factor analysis, the convergent validity of a group of manifest indicator variables is demonstrated if each indicator displays factor loading that's significantly different from zero. That is, if the t statistic or z statistic for each indicator's factor loading is significant. The idea is that if all of the items are statistically significant, it tells us that all of the items must be measuring the same underlying construct. In other words, the items are converging or coming together in measuring the same thing. It's not a particularly strong test of validity, but it's worth reporting. Let's go back and look at the table and see what we have. On page 12, we have our table 17.2, the table that gives us reliability, etc. We're still thinking about these individual questionnaire items and their psychometric properties in measuring exercise behavior. Previously, we talked about item reliability for V76 was pretty good at 0.81, less impressive for V79 at 0.44. But what about convergent validity? These two items would show convergent validity if both of them are statistically significant, if their standardized factor loadings are significantly different from zero. Well, this standardized factor loading for V76 is 0.90. That's pretty far away from zero. Is it far enough away to be statistically significant? We look under the heading T. We see the T statistic is 12.63. There's an asterisk there. What does the asterisk means? Asterisk means that it's significant. P is less than 0.001. So yeah, V76, its factor loading of 0.90 is significantly different from zero. V79, its factor loading of 0.66 is significantly different from zero. So both 76 and 79 show decent item reliabilities, and they're both significantly different from zero, and that means they both show acceptable levels of reliability and acceptable convergent validity in measuring the factor exercise behavior. Again, we'll come back and summarize the results in general before long. Let's keep plowing ahead. We're on page 13. We talked about convergent validity. We moved on to page 14 and some new concepts. Page 14, we turn to this. Results related to the latent factors. Now, to refresh your memory, what are the latent factors? Latent factors are represented by the ovals in that handout that I gave to students in my Psych 400 class. First page of the handout shows the confirmatory factor analysis model. One of the latent factors is represented by this oval for exercise behavior. One of the latent factors is represented by this oval for health motivation. How good are the psychometric properties for this factor, and so forth? That is what we turn to now on page 14. Dr. O'Day now turns her attention to the latent factors, the hypothetical constructs represented by ovals in figure 17.1. When she refers to a composite in the following section, she's referring to a group of indicators that were intended to measure the same underlying factor. With the figure that we showed you before, these are the two indicators that are a composite used to measure exercise behavior. These are the three indicator variables that are used as a composite to measure the factor health, motivation, and so forth. What does she say? Psychometric properties of the latent factors. When performing CFA, it's possible to compute composite reliability index for each of the hypothesized latent factors, that is, each of the ovals. This index is similar to coefficient alpha and reflects the internal consistency of the manifest indicators that are hypothesized to measure a given factor. It's been recommended that these indices should exceed 0.70 or possibly 0.80. Table 17.2 presents reliability estimates under the heading Composite Reliability. For all 6 factors, composite reliabilities exceed 0.70, which is the minimally acceptable level. What are we talking about? Let's go back to our table. This is the table that's on page 12. We're now looking under the second set of statistics, the columns that are headed Results for the Composites. Under Results for the Composites, under the heading Composite Reliability, composite reliability for exercise behavior is 0.76. That's bigger than 0.70. That's minimally acceptable. Composite reliability for health motivation is 0.84. That's bigger than 0.70. That's bigger than our minimally acceptable value. The same is true for each of the composites. For dislike of exercise, it's 0.92. For desire to be thin, it's 0.85. Composite reliability for each of these factors exceeds 0.70, exceeds the minimally acceptable value for composite reliability. Going back to page 14, where we had left off, we continue with this paragraph. Table, I talked about that. We go to the third paragraph of her write-up. When performing confirmatory factor analysis, variance extracted estimate for a given factor indicates the variance indicates the amount of variance that's captured by that factor in relation to the amount of variance that's due to measurement error. Table 17.2 shows that variance extracted estimates for the 6 factors in the current analysis range from 0.54 to 0.87. Each of these estimates exceeds the criterion of 0.50 recommended by Fornell and Larker. What are we talking about? We go back to the table that's on page 12. The last column is variance extracted estimates. Ideally, we want these to be bigger than 0.50. For exercise behavior, variance extracted estimate is 0.63. That's bigger than 0.50. For health motivation, it's 0.64. That's bigger than 0.50. If we look at each of these latent factors, variance extracted estimates all exceed 0.50, exceed the minimally acceptable values. So that's good. We've gotten past that hurdle. We go back to page 14 and final comments on these psychometric properties. Preceding section shows that the latent factors illustrated in 17.1 display acceptable psychometric properties. This is a good place to end part 3 of my video series. We'll begin part 4 of my video series, with the section correlations between factors. That'll be in part 4.